You're out doing some yard work one sunny day when you decide your hedges need pruning. As you grab a pair of shears, being the excellent MEAM student you are, you immediately begin analyzing the static loading conditions. Assuming you apply the same force to each handle, you want to find out how much force is applied to a branch when you make a cut. First, we need to know exactly what the shears look like on the inside. Take a look at the following explode animation to understand how the parts interface. To analyze the forces, we can separate the shears into four main pieces: the bottom handle, the top handle, the bottom blade, and the tab. Here's the free body diagram for the bottom handle. Next, we consider the free body diagram of the top handle. Notice that the internal forces at pin joint C cancel out with the corresponding forces acting at C on the bottom handle. The diagram for the blade looks like this. The internal forces at pin joint D cancel with those acting on the top handle. Lastly, the diagram for the tab is rather simple, as it's a two-force member. Notice that the FAB vectors not only cancel each other out, but also counteract the other FAB vectors we previously considered. With all of these free body diagrams, we have a lot of choices for our equilibrium equations. Consider our unknowns: F cut, FAB, CX, DX, CY, and DY. That's 6 unknowns, so we'll need 6 equations. Let's do a moment balance about point C and a force balance on the bottom handle. This gives us our first 3 equilibrium equations. Next, we'll do a moment balance about point D and a force balance on the top handle. This gives us our last 3 equilibrium equations. We now have a system of 6 equations and 6 unknowns, allowing us to solve for F cut in terms of F hand. And that's it! Now we can put our shears back together and finally get back to gardening.